The lesson outcome for this video is, I can simplify rational expressions after factoring quadratics. So we are going to use a similar process as we have the last couple of lessons, and that is we need to simplify this rational expression, again, polynomial in the numerator, polynomial in the denominator, fraction bar in between, that's a rational expression. We're going to cancel out common factors to simplify this. Now remember, in order to cancel out common factors, we need this to be in a factored form. Right now, this is not factored. This is a quadratic expression with 3 terms, and so is this, and therefore we can't start canceling. This is, again, one of those most common mistakes people want to do, is they want to cancel this like that. We cannot do that. That is a very big problem if we do that, because we only can cancel factors, and these are currently terms. So what we have to do is we have to factor, the numerator and the denominator. And to factor quadratics, we remember that when a is 1, we can simply put 2 sets of parentheses. Now I'm going to actually work upwards here. Hopefully that works for you guys. We put our 2 sets of parentheses, and we have to figure out what goes inside those parentheses that would, if we FOIL it, get us back to this expression here. So we always take that C term. Remember C? Let me get my green here. C is this term right here. We always take that off to the side and think about what are the factors of 2. Well, 1 times 2 is 2, and that's the only factors. And then we have to decide which of those factors adds up to our middle term. Hopefully you remember this process. Our middle term of 3x, or 3 in this case, positive 3. Well, 1 plus 2 is 3, so those are the factors we're going to use. So we can put x here and here, because x times x gives us that x squared. And then we're going to put the 1 and the 2 into our parentheses, so plus 1 and plus 2. Again, if we were to do FOIL with these 2 binomial factors, we would arrive back at this expression, and you can try that if you'd like. So now that we've factored this, we could cross that out, and now we're going to do the same work to the bottom here. All right, so again, we need to write that C term, again, since a is 1, always pay attention to that, but we have that C term right there, 5, and we have to write the factors of 5. 1 times 5 is 5, and that's the only pair of factors that there is. Again, we need to look for the ones that add up to 6, positive 6, and 1 plus 5 is in fact 6. So we can go ahead and put our 2 sets of parentheses down here, and x times x will give us the x squared, and the plus 1 and the plus 5. Again, if we FOIL this out, multiply this, we will get this here. Now, we need to cancel any common factors. Notice we have 2 binomial factors up here. They're being multiplied. 2 binomial factors here being multiplied. So unless we have a common factor in both the top and the bottom, if we have one, I should say, we can cancel it out. And we do have one. I hope you noticed that. We have an x plus 1 and an x plus 1. So we can cancel those because there's 1 in the top and 1 in the bottom, numerator and denominator, and our final answer therefore will be x plus 2 over x plus 5, the binomial factor that is left in the numerator and in the denominator. Let's try another one. So we have x squared plus 6x plus 8, and then x squared minus 4x minus 12 in the denominator, and again we're going to factor these. We're going to use the same process because a is 1. So we're going to write that 8 over here, and we're going to write all the factors of 8. Well, 1 times 8 is 8, and 2 times 4 is 8. Which of those adds up to 6, positive 6x? Well, 2 plus 4 does. 2 plus 4 is 6. So we can write our factors, our binomial factors here, x times x, and we're going to put a plus 2 and a plus 4. Hopefully you remember all these factoring steps. In the denominator, again, a is 1, and so we're going to take this value. Now be careful, that's a negative 12 for our c value, and we can write the factors of 12. 1 times 12 is 12, but one of them needs to be negative because it's a negative 12. 2 times 6 is 12, but one of them needs to be negative. And 3 times 4 is 12, but one of them needs to be negative. Which of these adds up to negative 4? Well, to be honest, none of them yet. This one right here adds up to positive 4, but we'll need to switch the signs to positive 2 and negative 4 to get the negative 4 that we need for that b term. So these two multiply to give us negative 12 and add to give us negative 4. X times x, and we're going to put the plus 2 and the minus 6. Again, at this point, if we have any factors that we can cancel, we go ahead and do so. We have a common binomial factor of x plus 2 and x plus 2. Our final answer is x plus 4 over x minus 6. Again, you cannot cancel these x's right here because they are terms. This is our final answer. Okay, so one last example, and this is actually going to connect a couple of things that we've done in previous lessons. If you remember lesson before this one, we talked about making sure to factor out a GCF to see if there's a common factor after doing that. And then we've been talking about factoring quadratics in this lesson. So here is the thing. We need to always, before we start factoring a trinomial like this, a quadratic situation, we want to look for a GCF first. I didn't talk about that in the previous two examples. I probably should have mentioned it. But this is where I want to make sure that we look ahead at, is there a common factor in our three terms? And there is. 2x squared is divisible by 2, 4x is divisible by 2, and so is negative 6. So we are going to always start by factoring out a GCF if there is one. When we do that, our 2x squared, if we divide by 2, we're going to be left with x squared, plus, we have 4x divided by 2, and we have 2x here, and then minus 6 divided by 2 is 3. All right. And we can keep factoring that one right now, or we could go down and factor a GCF out of this one. Doesn't matter what order we do this process, but we do hopefully notice that this can also be factored. All right, so we're going to go ahead and realize that a is 1 in the parentheses. So we're going to take this negative 3, our c value, and put that over here. 3 is 1 times 3, but one of them needs to be negative. And notice that those do indeed add up to 2 right there, the b term. So now we can continue our factoring. Do not forget that 2 out front. So x times x goes here, and then minus 1 and plus 3. So that is our final factored form for the numerator. Now we're going to do the same thing for the denominator. Okay, so but before we start this denominator factoring, I do want to make a couple of quick fixes. Sorry about this, but this right here should be a 16, and this 8 here should also be a 16 to kind of do what I wanted to do in this problem. So if you want to fix that denominator there, that would be great. Sorry about that. So if we want to rewrite it totally, it's 4x squared plus 16x plus 16. All right, sorry about that. All right, so let's go ahead and start this one by factoring out a GCF if one exists. And one does, because this is divisible by 4, as is this, as is this. So we're going to factor out a 4 and say what's left. Well, 4 divided by 4 is 1, so just x squared here, plus 16x, if we divide out a 4, factor out a 4, we're left with 4x, plus, again, 16 divided by 4 is 4. So now we have factored out our GCF. Now we have a quadratic expression, trinomial factor here, with a 1 in the beginning. So since a is 1, we can take the c value, 4, it's positive, and write it off to the side. 1 times 4 is 4, and 2 times 2 is 4. In order to get the middle term, or b value of 4, we will need to use the 2 plus 2. So we'll keep that 4 there. Don't forget that GCF. Put our factor parentheses down. X times x will give us the x squared, and then we need the plus 2 and the plus 2. All right. At this point, we look at the factors of the numerator and the factors of the denominator, and we cancel anything out that is a common factor. What you probably notice right away is that x minus 1 does not exist down here, and x plus 3 does not exist down here either. So we can't cancel out any of our binomial factors, but we can simplify our 2 over 4 because they both have a factor of 2. So if I divide this 2 by 2, I get 1, and if I divide this 4 by 2, I get 2. And that is the only simplification we can do in this problem. Our final answer is x minus 1, x plus 3 over 2, x plus 2, x plus 2.